This is the blockchain session. You may have remembered this from last year. Thank you, John. You may remember this from last year when I banged on about digital currencies, blockchain, tax and welfare, and Bitcoin. You may have remembered that. So welcome and thank you for coming back for yet more punishment. That's all I can say. So Cliff has set me up a little bit earlier by using a few slides which you might recognise in this presentation, but also to raise expectations again about blockchain, about its potential. I think I'll quote Cliff here: is that blockchain could change the way we organise and live. So it falls to me to explain then how this is going to change the way we organise and live. I might not be able to do that, so I'll set that expectation to start with. However, it's worth mentioning last time that at that last presentation I talked about the government report, the Walport report into blockchain, its potential, known as distributed ledger technology, and its potential. There's a whole load of use cases in there which are very interesting about how it could transform government. Also, the financial services industry has continued to get really excited and quite overheated about blockchain. Many companies are setting up and yet more startups. And there are starting to be some consolidation around that, and there are some difficulties. We aren't quite seeing the excitement being materializing in the last year or so. So what I'm going to cover in this presentation is basically a little bit of recap on blockchain, what it is anyway, a little bit of background to how expectations have been set, talk about typical patterns, and this is the slide that Cliff showed you earlier about the famous slide about centralized, distributed, and federated in the middle. So we'll use that one and go into that and explore why that pattern works and why it doesn't work. Then we'll look at 8 use cases. These are Capgemini use cases. There'll be a quick run through some of them and then a little bit of a delve into a bit more detail in others. And then we'll look at, from those use cases, what makes them succeed or otherwise, what's really good from a business perspective. It's a business perspective. So this is about use cases. So we're not going to do a deep dive into the technology here. We can cover that in a little bit more detail outside the session in the demo area, if you like. But we'll then end up by looking at, well, what have we learned from that? What should people perhaps be doing with blockchain as far as proof of concepts and exploring that technology and seeing how far we can change the way we live and work and operate. So this is, again, some of the sorts of things which are being said about blockchain. It's going to be as big as the internet was in the 90s. I don't remember Netscape. Anybody remember Netscape? Yeah, and excitement. Everybody got so excited about the browser wars, and well, there actually was a huge amount of investment going on, loads of startups, and then there was a little bit of a bubble, and then there was a bust shortly after that. But the level of investment in this is actually greater than at that time. So it is, the amount of excitement is at least as equal to that. And people are saying things like, think about the blockchain as another class of thing like the internet. So it's going to be really big. Don't quite know what it's going to be, but it is going to be really big there. And it's going to be a new organizing paradigm. Now, there is something in that, as there is absolutely something in that. But what we're not seeing at the moment is how that is actually materializing. We'll try to delve into that in a bit more. Specifically in the financial services industry, it's much clearer. So Chris Skinner, who's a speaker about transformation in the financial service industry, he's got a really good video on this, which is on the Agents of Change website for Capgemini. But if you have a look at that, he regards it as reinventing the infrastructure that enables us to transact globally between institutions. So banks, your time has come here. This is something where the way that we pay for the services for banks, in the way value is moved, the way we move money, is changing. And you can all see there are things like TransferWise, not necessarily using blockchain, but there are ways of re-engineering the way value is moved between institutions, which are happening now. There's a lot of pressure on the banks, and that's why the financial services industry is pushing so hard on this. Chris regarded as, and this is a nice simple definition, it's a distributed database which everybody shares that you can trust. So a really simple definition of it, but basically, so what we're seeing here is quite a lot of hype around this. And do you remember the Gartner hype cycle? I've no idea where we are on that. there's no scale. Are we? Now, are we coming up here? Are we up there? Or are we actually down there? I mean, the trough of disillusionment one there is possibly best expressed by Dilbers, who there is quite a lot of disillusion, particularly among people who have to build and implement this stuff, because it is an immature technology still. So rushing in can be a dangerous thing. So what is it then? So let's just recap on that. Okay, decentralized database. That's not really that new. Some of us have been trying to do distributed database for a long time with varying degrees of success. But the idea, data stored in more than one place, almost anywhere potentially. Data can be, by data we mean almost anything. So it could be any form of data. So you can basically numbers, text, images, could be absolutely anything. And each entry is chained to the next. By that chaining idea, that sort of links with the cryptographic security thing there. It just makes it really hard to undo once it's chained together. It's immutable. So that's the property, one of the key properties of this. Stick it in there and nobody else is going to be able to change it without a lot of hassle. So you can trust the records which have been written there. And that's a key thing about distributed things. You need to be able to trust the distributed network. Process automation. We've just had a session, interestingly, about process automation here. The concept here is you can push some of the automation in process, the way events are handled, the way the data is accessed and controlled. You can push that down into a layer of technology and create atomic contracts, pieces of logic which say what happens next, who is authorized to do this for this next step to happen, who are the 2 or 3 people who need to sign up to and approve this before this happened. So there's logic in there as well, business rules, programs built into that data. It's a bit like sad database people like me, we'd say just stored procedures. It's quite a lot similar to that type of idea. So we're seeing not a lot of this stuff is really that new. The idea is it's just the extent of this being rolled out as a platform. Cryptographic security, again, nothing really new in the cryptography here. These techniques have been around for a long time. It's public key infrastructure. The clever things is you can vary the strength of that cryptography, how linked together the chains are, how hard it is to undo things, depending on who's accessing it and using it. If it's out there in the wild in public, clearly you need something pretty solid, to discourage people from fixing it. So Bitcoin is the example of that. If you want to clone lots of Bitcoins and spend them, you actually need an awful lot of computing power, something like the entire electricity consumption of Ireland, to undo and change the Bitcoin ledger. So that's not a great, I just realized that's not great for green computing, is it? That's not. Maybe that's what they mean by green computing. It's basically a bit of a problem there. So the way that cryptography works. There are different mechanisms of doing it, by the way. We'll come on to those in a bit of a second. And that protection enables, if large amounts of data are breached, then that can reduce the damage, because there's not much that can be done with that data if it's cryptographically protected and only certain people can use it. So the crypto helps protect and reduce the damage which can be done by any data breach. You can know when it is breached. Integrity is a key part of that. And the whole point of this then, so if those are the features, the whole point of the thing, or the way it's positioned, is it's about value transfer, digital value transfer. The idea is, we're moving information, but it's actually information representing value between participants in a network. So, and that could be value, any representation of an asset, a digital asset. So if there's something out there that you can fingerprint, it could be an individual, it could be identity, it could be that's fingerprinting. It could be a digital artwork or something like that. Or an artwork. You can make an image of that, and you can represent that by a cryptographic key to say anything that you can give a number and uniquely identify, and then put in here that this infrastructure provides the means to securely transfer the ownership of that asset. So that's really what it's about, or at least as much as we need to know for this session. There's a lot more you can find and read about this.